Okay, so we're going to learn about rational exponents, so exponents that are fractions today. Okay. We're learning to evaluate numeric exponential expressions containing rational exponents, learning to link the link between rational exponents and roots. Okay. And learning the meaning of a rational exponent of the form m over n. So consider 25 to the 1/2. What does it mean? So I'll give it away first and then I'll show you why. So 25 to the 1/2 does mean the square root of 25. Okay. So this is an exponent, so make sure it looks like a little exponent there. So why is that true? Okay. Well, we know that the square root of 25 is equal to 5. We just consider the positive square root. And that's because 5 squared is 25. And square and square root are inverse operations. So the square root of 25 is 5 because 5 to the power of 2 is 25. Now, let's raise each side of an equation to the exponent 1/2, because we're allowed to do the same thing to both sides. Which would mean that 25 to the power of 1/2 is the same as 5 to the power of, so what do we do when we have a power to an exponent? Multiply them, so we're multiplying 2 times 1/2, which gives me 1. Really good. Because you multiply the tops together, you get 2, bottoms together, you get 2, and 2 over 2 is 1. Okay? So in other words, 25 to the 1/2 is equal to 5. So if we look back, we've got the 5 on each side. And in this case, 5 is the square root of 25. In this case, 5 is 25 to the 1/2. So we can see that 25 to the 1/2 is the same as the square root of 25. They both equal 5 using the definition of what square root means, so these two also have to be the same. Okay. All right, we're going to do that again, but this time we're going to start off with why does 8 to the 1/3 equal the third root of 8? So we're mostly used to seeing square roots at this point, where there is not a little number inside a little root. And if that's when it is square root, there's a little 2 in there, but we never write it down. So if you just put a root sign with a little number in the corner, a 2 is understood to be a square root. Okay? So third root. So what does third root mean? It means what number multiplies by itself 3 times to give you 8. Okay? And we would be able to figure out that the third root of 8 is equal to 2. And that's because 2 to the power of 3 is equal to 8. Okay? 2 times 2 is 4, times 2 is 8. 2 to the power of 3 is equal to 8. So then we're going to put both sides to the exponent 1/3. So we get that 8 to the power of 1/3 is equal to 2 because 3 times 1/3 is 1. 3 times, yeah, I'll show this step here. So 8 to the 1/3 is equal to 2 to the 1, or 2. Okay, and again, we have the same idea we had in the last question. 8 to the 1, or the third root of 8 is 2. 8 to the 1/3 is 2. We use the definition of roots to get there. So that must mean that 8 to the 1/3 is the third root of 8. Okay, so those are a way we can arrive at the definition of a fractional exponent with a numerator of 1. Means the blank root of. So the meaning of an exponent of 1 over n . So 1 over x, or sorry, x to the 1 over n is the nth root of x. Okay, that's how you say it. Square root, third root, fourth root, fifth root, depending on the number. So the thinking is what number multiplies by itself n times to give you x. So 81 to the 1/2 means the square root of 81. What number multiplies by itself twice to give you 81? 9. Okay. 64 to the 1/3 would mean what number multiplies by itself 3 times? 3 times to give you 64, and that's 4. What number multiplies by itself 5 times to give you 32? That number is 2. Okay, that's what nth root means. So think and evaluate. So try without a calculator if you can. It will really serve you well for logarithms next year and advanced functions. If you can do it without a calculator, start off needing a calculator and then you get used to the numbers, which will be same ones over and over again as we work through. That's good too. So next year in grade 12, you'll be able to go straight to the answer. This year, I'd like you to write it first as a root, just to reinforce the connection between rational exponents and roots. So the third root of 27 means what number multiplies by itself 3 times to give you 27? So if you had no idea, you'd start off with 2 times 2 times 2, or 2 to the power of 3, that's 8. 3 to the power of 3, 27. So the answer is 3. The third root of 27 is 3. So 49 to the exponent 1/2 means the square root of 49, which means which number multiplies by itself twice to give you 49, which is 7. (16 to the power of 1/4 means the fourth root of 16, which means what number multiplies by itself 4 times to give you 16? 2. 2 to the 4th is 16. 1,000 to the exponent 1/3 means the third root of 1,000, which means what number multiplies by itself 3 times and gives you 1,000. 10 times 10 times 10. 16 to the power of 1/2. So we could write that as, we can apply that to the exponent to the numerator and to the denominator. And then we can rewrite that as the square root of 16 over the square root of 25. Square root of 16 is 4, square root of 25 is 5. So that's actually 4 effects. All right, now we're given them as roots. So the third root of 343 we can do trial and error. So you can try 2 cubed, no. 3 cubed, no. 4 cubed, no. 5 cubed, no. 6 cubed. It turns out 7 cubed. Okay. Or you can use the button on your calculator. So you'll find a button that looks like. You should see one that looks like this, possibly. Does anyone have that button on their calculator? So you should be able to type in that. So on my calculator, I go 343 and then press that button, which is a shift button on my calculator, and then type in 3, and it gives me 7. Okay? Some, you have to type the 3 first, then that button, then 343. It depends on your calculator. I'll just pause and make sure everyone can get that on their calculator. So that turned out to be 7. 32 to the negative 1/5. Any ideas what I would do first? Good. Well, flip it so that we get a positive exponent. That is exactly what I would do first. 1 over 32 to the 1 positive 1/5. Okay. Which is 1 over the 5th root of 32. And if you don't know what the 5th root of 32 is, then don't forget about the 1 on top. That's one of the most common errors because you're focusing on the bottom. Okay. So it'll be 1 over the 5th root of 32 is 2 because 2 to the power of 5 is 32. Okay. This one's already in radical form or root form. So the 3rd root of 64. What number multiplies by itself 3 times to give you 64? 4. And what number multiplies by itself 4 times to give you 625? 4th root of 625. 5. Okay. What do you think the first step for I would be? Flip the fraction. Yes. So flip the fraction to the positive 1/3. Fraction to a negative exponent rule would be our first step. Then we can apply that exponent to the numerator and the denominator. You can skip this step if you want and go straight to 3rd root of 8 over 3rd root of 27 if you wish. Okay. And then you have to figure out your roots. So the 3rd root of 8 is 2, because 2 cubed is 8. And the 3rd root of 27, 3. 2/3. Okay, negative 125 to the 1/3. So that means the 3rd root of negative 125. We're not used to being able to have negative signs under a root, a radical symbol, are we? But 3rd root, it's okay, because negative 5 to the power of 3 is negative 125. You see that? So odd roots can have negatives, whereas even cannot have negative under them. Odd can. Did I miss any? Are you on this one? Okay. All right, so we're just multiplying 2 of them together. So the first thing I would do for this one is rewrite it as the 3rd root of negative 8. Because I don't see same base or anything. And then this one, I would rewrite as first of all, 1 over, in brackets, negative 32, because the base is negative, to the positive 1/5. Which is, third root of negative 8 is negative 2 times 1 over the 5th root of negative 32. Which is negative 2 times 1 over, what's the 5th root of negative 32? Negative 2, good. And then I'm just multiplying fractions together. So I multiply the tops together and I get negative 2. Multiply the bottoms together and I get negative 2. And then when you divide them, you get positive 1. So complicated way of writing 1 up here. Okay. Complicated way to write the number 1. Okay, L is already in radical form, the root form. So I want 1 over the third root of negative 1,000. And then that would never be the textbook answer. They would always put the negative either with the numerator or even with the fraction bar. Okay. Bump it up. All right, evaluate 27 to the 1/3 squared. So, knowing what we know, we could rewrite the inside to third root of 27 squared. Third root of 27 is 3. Squared is 9. Okay, I want to look at this in a different way now. What can we do when we have a power to an exponent? Multiply. So if I multiply the exponents, I get 27 to the 2/3. Does everyone see that? Okay. So 27 to the 2/3 must be 9. How does that work? Okay. So you have to remember when you're doing this that the bottom number represents the root and the top number represents the exponent. And we almost always do the root first. Third root of 27 squared, just like that step there. 3 squared is 9. So we now know the meaning of a rational exponent with a numerator other than a 1. Okay? The top number is the exponent, the bottom number is the root. So there's that given to you in a little box here. So if you have x to the m over n, it's the same thing as the nth root of x to the power of m. And then there's also another version of this, which may help you in simplifying things. Also next year with logarithms, it may help you as well. You could also, remember I said 99% of the time this is how you're going to look at it. 1% of the time you'll do the exponent first and then take the nth root. Okay, so they both work. But when we're evaluating, this is the way we're going to do it most often. So most often you evaluate the root first and the exponent second. Okay, so think and evaluate, no decimal answers. So we would think to ourselves root first, exponent second. So I would write it like that. The third root of 125 squared. So then to get the third root of 125, if I'm not using my calculator, I'm asking myself what number multiplies by itself 3 times to give me 125. 5. 5 squared is 25. Okay, try the next 3 on your own. I'll give you some time. Okay. Volunteer for B. Darius?
I got in brackets, I did the 5th through the 32, the 3 on the outside.
Awesome.
And then I gave me 2 P's, and then
Awesome. How many people got 8 for that one? Good. Great. How about a volunteer for C? Jack?
I did 1 over 81 with the exponents 3 to the 4th.
Yep.
And then I did 1 over, in brackets, the 4th root of 81, the exponent 3.
Yep.
And then that gives me 3 cubed, which is 1 over 27.
Awesome. How many people got 1 over 27? Remember the 1. Good. And then, yeah.
If you didn't do the first step, you went right to the second step, and that's totally fine.
Yeah. Volunteer for D. Darius.
I did the 3rd root of -27.
The 3rd root of -27
Kept the 4 outside.
to the 4th. Good.
Then I gave me -3 to power 4.
Okay, do I need brackets around -3? Yes. Good.
And that gave me positive.
Yes. How many people got positive 81? Excellent. Okay, good. All right, now we have a fraction one, 125 to the -2/3. What are we thinking for the first step?
Flip the bracket.
Yes. So bracket 8 over 125 to the +2/3. And then if I can apply that exponent to the top and the bottom in my mind, I could go straight to 3rd root of 8 in brackets squared over 3rd root of 125 in brackets squared. Okay, so I'm applying that exponent of 2/3 to the top and to the bottom. All right, so then the 3rd root of 8 is 2 squared. 3rd root of 125 is 5 squared. So you end up getting 4 over 25, not 10. A common mistake is 10. Your brain does that unconsciously when you see a 5 and a 2. So just be careful. Get through. F is a different setup. Anyone have an idea for this one? Did you first draft?
I solved inside the brackets first.
Okay, so you did the.
So that becomes 2 to -5.
Good.
And then I did 1 over 2 to the 5th.
Yes.
And I did 1 over 2.
Good. Does that make sense to everybody? Do the root and then the exponent. So when it's negative, you have to use the negative exponent now. Good. Okay, here's a starred one here. So for this one, we actually have to use the exponent rule, where when we divide powers with the same base, we keep the base and do what with the exponents? Subtract. So my first step is not pretty, but here's what it is. 27 to the -1 minus -2/3. Now, how do you subtract, end up adding really those exponents? Common denominator. So right now, this denominator is a 1. Does everyone see that? And the common denominator of the exponents alone would be a 3. So I'm going to have -3 over 3 plus, because minus and negative is adding, 2/3. Which is going to give me 27 to the negative 1/3. Because now that I have a common denominator, I keep the denominator and add the numerator. Negative 3 plus 2 is negative 1. And now it becomes a regular question. A negative exponent. So I would probably do 1 over the 3rd root of 27. Which would be 1/3. So there's an example where we had the same base that we were dividing, so we could use an exponent rule. Here we have the same base, but we're subtracting, so we can't use an exponent rule. Okay? We have to do them each individually. So this is using dividing powers with same base. And this one, no rule for subtracting powers with same base. So we have to do each one individually. So if you were just looking at 16 to the negative 1/4 as a question, you would first probably do 1 over 16. You could go straight to the 4th root, or to the positive 1/4. And same thing here because I have a negative exponent. So that's the 4th root of 16. Square root of 16, so I don't need to write that 2 in the little crook, but I can if I want to. Cubed. So that's going to be 1/2 minus 1 over 8, sorry, 4 cubed. Which gives me 1/2 minus a 64th. So I'm going to need a common denominator in order to subtract them. Does 2 go into 64 evenly? Yeah, so 64 can be my common denominator. I had to multiply the bottom by 32, so I have to multiply the top by 32. Subtract 32 minus 1 is 31 64ths. 31 64ths. Okay. Try I. Okay. Anyone want to share the first step for this one? No? Okay. I would have, I guess, done the 4th root of 81 cubed plus, that one's already to go, 2, minus the 4th root of 256 is 4. This 4 to the 4th is 256. So the second two are easy. So that's going to be 3 cubed plus 2 minus 4, which is 27 plus 2 minus 4, which is 25. Yeah? Okay. All right, this one, it looks complicated, but it's not too bad. In the top, it's a subtraction. And I would just rewrite in root form, so square root of 4 cubed minus third root of 8 over fourth root of 16 times square root of 25 so square root of 4 is 2 cubed minus 2. The third root of 8 is 2. Over fourth root of 16. What number multiplies by itself 4 times to give you 16? 2. Square root of 25 is 5. Two cubed is 8. Take away 2 over 10, which gives me 6 over 10. That reduces, because you can divide top and bottom by 2, to 3/5. So it took a lot of steps, but it wasn't too hard. Okay. All right, these ones are a little bit different. You can see right away in the first one, you've got the common bases everywhere. Simplify and evaluate using appropriate exponent rules. So one way you would know something was different was you would go to find the square root of 2 and it wouldn't be a nice number. Okay, so what number multiplies by itself twice to give you 2? It's not a nice number. 1.41 something. Okay, on forever. So you're trying to look for a different way to get to the answer, and it tells you to simplify using appropriate exponent rules. And you always simplify before, simplify comes first, evaluate comes second. So in order to simplify using exponent rules, everything would have to be written as exponentials, okay? Square root of 2 is written in root form right now. How could I rewrite square root of 2 so it was 2 to the something? 2 to the 1/2. Does that make sense to everybody? Square root of 2 is the same as 2 to the 1/2. That's how we started off, right? Okay. Okay, then how about writing the third root of 2? How could I write that using an exponent? 2 to the 1/3. Good. And then the denominator is already written with an exponent. Okay, so in the top, I'm multiplying powers with the same base. Bases are the same, so the rule is keep the base and add the exponents. I still have the denominator, but I'm not dealing with it right now, but I still got to write it in. So how do I add those exponents? Common denominator, good. So what's the common denominator? 2 and 3? Good. So I'm going to make it 2 to the something out of 6 plus something else out of 6. So to get from 2 to 6, I had to multiply by 3. From 3 to 6, I had to multiply by 2, so I multiply the top by 2. But that's still all over 2 to the negative 1/6. So that's going to give me 2 to the 5/6 divided by 2 to the negative 1/6. Which means I would now be dividing powers with the same base. And the rule for that is to keep the base in, subtract the exponents. Good. So it would be 2 to the 5/6 subtract negative 1/6. I've already got a common denominator, which is good. What happens when you subtract a negative? You add, yep, so you get 2 to the 6, 6, which is just 2 to the 1, right? Which is just 2. So it turned out to just be 2 through all that work. All right, B is similar ideas. So first of all, when you have this 5 isn't in the little crook there, it's out in front. So what does 5 root 5 mean? What operation is happening between 5 and square root of 5? Multiplication. Okay. So I'm going to rewrite first the inside here as 5 times 5 to the 1/2 all to the negative 2. And again, I know that I have to do something different because if I tried the square root of 5, it's not a nice number. Okay? Not like the square root of 25 where I know it's 5. So if I start inside the brackets, how do I multiply those two things together? They have the same base, remember. And the exponent on this is a 1. Keep the base and add the exponents. Okay, so that's going to be 5 to the 1 plus 1/2. All to the negative 2. And then in order to add them, I need a common denominator, which would be 2. So that's going to be 5 to the 5 to the 3 over 2 to the negative 2. Okay, what's the rule when you have a power to an exponent? Keep the base and multiply. So 5 to the negative 3. So 3 over 2 times negative 2 is negative 6 over 2, which is negative 3. Everyone agree with that? I'm just multiplying the exponents. And then 5 to the negative 3, something we went over yesterday, we reviewed, that'd be 1 over 5 to the positive 3, which is 1 over 125. Okay, I'm going to give you guys time to try this one. I'm seeing as I walk around 2 different final answers. One is 3 and 1 is 1. So let's see which one wins out. So everyone's okay for that step? Yep. Then I'm going to, in the numerator, keep the base and add the exponents. But they already nicely have a common denominator for me. So right there, I can see the answer should be 1 because I have the exact same thing in the top and the bottom. If I use an exponent rule, which it asks me to do, I would keep the base and subtract the exponents, which would give me 3 to the 0, and any number to the 0 is 1. Okay? 3 to the 2 minus 2 is 3 to the 0, any number to the 0 is 1. So with the rest of that blank side, I want us to write down some commonly used powers, okay? So that you're not as tempted to check everything on your calculator and that you get used to seeing those numbers. So 2's go fairly high. So 2 squared is 4, 2 cubed is 8. 2 to the 4th is 16. So these are ones that hopefully over time you'll get used to seeing. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128, and 2 to the 8th is 256. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. 3 to the 5th is 243. 3 to the 6th is 729. That's usually what you would be responsible for threes. Okay? 4 squared is 16. 4 cubed is 64. 4 to the 4th is 256. 4 to the 5th, I don't know what you had. 1024 maybe? Yeah. And that's about as much as you'd be responsible for fours. Okay? 5 squared is 25. 5 cubed is 125. 5 to the 4th is 625. And that's usually as much as you need for fives. Okay? For sixes, 6 squared is 36. 6 cubed is 216. 6 to the 4th, I'm not sure, but I wouldn't pass there very often. 1296. And then 7 squared is 49. 7 cubed is 343. And then usually 10s, but 10s hopefully are easy. 10 squared is 100. 10 cubed is 1,000. 10 to the 4th is 10,000. 10 to the 5th is 100,000. And those are just good reference points for when you're figuring out the 5th root of 243. It's 3. Okay? Thank you very much.
No problem. Have a good one.
You too. Okay, or if you want to know what's the 3rd root of 125, it's 5. Okay? These are just ones that hopefully by the end of next year, for sure, you just kind of know in your head. You don't have to go to your calculator for, but good to have this out while you're doing the practice. Okay.